Easy Calculus, Lesson 5.1, Extreme Values of Functions. This gets complicated fast, but we'll start off where it's not too bad. Early on, calculus was really handy in finding extrema, and I've taken AP Calculus a long time ago and got back into this recently, and this actually stuck with me because back then we did not have graphing calculators to rely on. So we have what are called maxes and mins. And they're just peaks and valleys. This is a local because there's something higher out here, and this is a local because there's something higher down here. If we didn't, we could also call it an absolute max or min. So I'll just do one of these. This would be local because the other one's just slightly bigger, local min. And this would be an absolute max, but an absolute max is also a local max because a local max by definition is give me a range, give me a domain, and is it the biggest in that domain? So we'd say from here to here. Yep, then it's a local max. Oh, by the way, it's also an absolute max. Don't get hung up on it. So we have an extreme value theorem, EVT. If the derivative is continuous on a closed interval, and this one is so ticky-tacky, continuous closed interval, then there's a max and a min. That's it. Got a continuous one, there's a max and a min. What's the difference between absolute and local? Well, I just told you. These are both local. All right. Absolute or global means that's the biggest for the entire domain of the graph. Local means just some set domain that I give you, from 3 to 5, from 1 to 4, that sort of thing. Now, most importantly, because we get to use calculus, at these values, the derivative is 0. So you're going to take the derivative of your function, set it equal to 0, and see what the heck happens. Now, is that the only point where the derivative is 0? No. More later. And more to the point, is that the only point of interest? Also no. You might have other points where it's undefined. Pardon me, the function's defined, the derivative is undefined. So a critical point and a stationary point, the difference is stationary point is where the derivative is 0. Critical is derivative equals 0 and, let's say, or undefined, or something else interesting is happening there. It could be endpoint, that sort of thing. But the big one is stationary. That's where the derivative is 0. So the extreme value theorem really tells us, since we're on a closed interval, just got to check the endpoints. So if I give you x to the 2/3, you need to find the endpoints and tell me what the heck's going on. So at 2, we'll take the derivative first. F prime of x equals 2 over 3 x to the 1/3. It's x to the negative 1/3. I threw it on the bottom. Critical point here, but not a stationary point. X can't equal 0, so that becomes a critical point. And that's only in the derivative. 0 is fine in the function. So something weird's going on there in the derivative. And then we check the endpoints. F of -2, not the derivative, is third root of 4, about, not a very big number. I'll leave it like that. And f at 3, the other endpoint, is about 2.08. So we always seem to want to cheat and just, let's throw it on the calculator, see what's going on. But just remember, it's from -2, close dot, to 3. So we would have to go look at this critical point, plug that in, f of 0 equals 0, and we would say absolute max, absolute min. And this is a local max, because again, there's an interval I can define it over. Another one, find the extreme values of 1 over root 4 minus x squared. Well, in order to save time on the video, and you can try this on your own, I'm going to say the derivative, after doing some nasty work, not that nasty, is x over 4 minus x squared to the 3/2. X cannot equal 0. Oh, and by the way, in the domain, which was given, it goes from -2 to 2. Extreme value theorem does not apply. Why not? It's not closed. Got to be a closed interval. Doesn't mean we can't find a max and a min. Just means it doesn't apply, that there isn't a guarantee of a max and a min, which I'll show you in a second. So, pardon me, x equals 0 gives me f prime of 0 equals 0. So there's going to be a min or a max there. Let's see what's going on. 0 equals 1 over 4. Notice again I went to the original function. Turns out that is an absolute min, because when I graph it, I get this funky little thing, and there it is, 1/2 at 0. So people will immediately say, great, so the maxes are at -2 and 2. There is no absolute max, because it's not a closed interval. We can't say it's at 2 or -2. We can't say it's at the point just barely short of 2 or -2. Doesn't work. So the other stationary point, if you graph x to the third, you take the derivative, and you check the derivative at 0, you say, hey, it's 0. I don't see a min or max here. Call that a point of inflection. Much more to come on that. But that is a stationary point, because the derivative equals 0, stationary, 0, stopped, stationary, whatever you feel like using to remember. But you just got to watch and check, see what's going on. So, find the extreme values. This one's piecewise. So, graph the sucker. X is less than or equal to +1. We got 5 minus 2 is 3. Include this point. It's an upside down parabola. It hits at 5. So we got something like that going on. And then x plus 2 greater than 1, 2, 3. So it looks like it's a circle around that and goes like that. Yeah, I think I got it right. So, no absolute max. It's infinity, but we're not going to say that. All right. Let me make sure I'm being clear here. So, the only stationary point is at 0. So we have a relative or local. I like to write local. Max at x equals 0. And a lot of people say, well, don't we label both points? And I say, sometimes we do, sometimes we don't. Read the full question. Local min, strictly by looking at the graph, at x equals 1, 1 comma 3. That's it. That's it. There's no absolute max, no absolute min, because it goes on forever. to infinity. There's no endpoints. And find the extreme values of natural log. What a nightmare. I can find the derivative, which I'm not even going to pretend to say, oh, I did that. Just blast it out. Oh, well then we have some stationary points here at x equals plus or minus 1. We can put anything in because of the absolute value, so the domain goes forever. There's no way to get 0 on the bottom. So I'd have to check those points. Well, for a change, we're just going to straight graph it. See what happens. Y equals, let's clear this, natural log, quit out of that, y equals, not to my, did I clear this whole thing? Alright, natural log, math, enter, and yes, I know there's other ways to find that, fraction, x over 1 plus x squared, 1 plus x squared, enter, got my parentheses, shouldn't matter, but might as well be thorough. Parentheses, and graph it. What a pain in the butt. Should be something going on, negative 1 and 1. Hey, there is. And then I forgot to check its natural log. Naughty boy. So we've got this weird little thing going on here. We've got negative 1, 1. We're going to have absolute max at x equals negative 1 and 1. I'm not going to find the other value, just it's natural log of 1/2 if we wanted to do that. Absolute value, 1/2, whatever. Not going to get into that. Yeah. Where was I? What's going on here at 0? Can I take the natural log of 0? And the answer is I cannot. So this goes down forever and ever and actually never hits. So there is no absolute min. If I didn't graph that, might be a little tricky. So, yeah, that's it. Lots and lots and lots builds on this lesson. So if this is like kind of goofy, don't be surprised. We'll make it all up to you eventually. Happy mathing.